myself Dr. Divya, Assistant Professor at the Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will know or learn the proximate analysis of coal, which is very useful before its application to any field. So here are the topics. First, the ranking of coal. So how the coal is being ranked depending on the characteristics or the properties of that coal. Then analysis of coal, how the analysis is done. Then types of analysis. So there are two types of analysis, proximate and ultimate. So we will see in the detail. Then additional characteristics of coal, proximate analysis and its significance. In this proximate analysis, we have moisture, volatile matter, ash and fixed carbon content. So there are a lot of products from the coal. So it is very useful and it is mandatory for the analysis of coal before we use for any application. So ranking of coal. So coal has large amount of carbon. So this carbon content increases for its evolution from peat to anthracite type of coal. So the carbon content increases from peat to anthracite type of coal. So this carbon content, as the carbon content increases, the ranking is high. Because the more the carbon is there, the more energy it will produce. Therefore, it will be having highest ranking for that particular coal. So obviously, when the carbon content is low, water content is high here. So that will have low ranking for that particular coal. So example is like brown coal and hard coal in the high ranking. Brown coal is having high water content, therefore low ranking of the coal is given, whereas hard coal has high ranking coal because it has highest concentration or the percentages of carbon. So of all the coal that is present, 47% of coal is under brown coal and 53% is of hard coal. So in this hard coal also there are two types. So bituminous and anthracite comes under hard coal. So we have seen in the previous session, like from the peat it is forming to anthracite. So in between there is bituminous and anthracite. So these two are forming the hard coals. So bituminous is 52% and anthracite is only 1%. It means the highest ranking coal is only 1% available in the worldwide reserves that is present. And in the brown coal, lignite is 17% and subbituminous is 30%. So the formation of lignite to subbituminous, the subbituminous coal is high in percent when compared to lignite. So this lignite is used in electricity generation. Subbituminous coal is used for steam coal and ultimately for the electricity generation, cement plants, industrial boilers, etc. So these are some of the examples. Again, bituminous is, before becoming the coal bituminous, it is subbituminous. So once it is becoming bituminous, it has highest percentage of carbon. So therefore, it is used in boilers and also for the electricity. Then this also has coking coal. So this coking coal is used in the steel manufacturing, carbon steel we call. So that steel manufacturing, we use a bituminous coal. Anthracite is the highest ranked coal that is present in the world reserves. So we know that most of the coal is used for the electricity. So it does not give any fumes. So for also for any applications in the industry. So if we use this coal, there is no fumes coming out from the smoky fumes coming out from the coal and therefore used for the domestic and industrial purposes. So why we really require the analysis of coal? Because we know that highest percentage is used for generating electricity. So this is the world biggest source used for generating electricity. So before we are using this for electricity, we have to analyze the coal to know the chemical properties whatever are present in that particular material or coal. So that decides the price of that particular coal. So obviously when it is low ranked, it has low price. So when it is highly ranked, it will be having high price. So that is how the coal price is decided. So the analysis plays an important role in deciding the price of that particular coal. Then to determine the quality, so that also decides the quality of that particular coal. So to specify use of coal for a particular purpose. So we want to use it for a particular purpose like boilers or electricity. So for that we need some properties of coal. So that will be done only through the analysis, chemical analysis. It also helps in calculating the theoretical calorific value that defines the heat generated from that particular coal. So calorific value of coal, and also helps in calculating air requirement for complete combustion. So what is the ultimate reaction that is going to take place? Combustion. So it requires some air to combust that particular material completely. So we need to understand how much air is required for the complete combustion, and therefore we can use it for the proper designing of furnace. So these are the important aspects that has the purpose for coal analysis. So in order to assess the quality, to understand the quality or examine the quality, there are two types of analysis, that is proximate analysis and ultimate analysis. Proximate, the word itself gives us an understanding that that is a preliminary test. It is just like a preliminary test that we do after after mining the coal from the coal mines. So this includes moisture, determination of moisture, volatile matter, ash, fixed carbon. Moisture, volatile matter, ash, and fixed carbon. So these four tests comes under proximate analysis for the coal. So this gives quick and valuable information regarding commercial classification. So this will give an understanding of classifying into different types of coals, and also determination of suitability for a particular industrial usage. So this is how the proximate analysis is the first foremost step that we take immediately after mining the coal from the mines. Next is the ultimate analysis. So ultimate analysis is just like a chemical analysis. It determines the carbon, hydrogen, nitrogen, sulfur and oxygen in the coal. So since it is used for determination of elements, so most of the time we are determining the elements present in the coal. So therefore it is also called as elemental analysis. So this ultimate analysis is also called elemental analysis because we are determining carbon, hydrogen, nitrogen, sulfur and oxygen content in the coal. So this analysis gives exact results and are useful in calculating the calorific value of coal using Dulong's formula. So we have seen the calorific value, how the calculations we do. So this helps in calculating the calorific value, that is a main determinant for any particular coal before we use it for any applications. So if we see in this chart, this is the low ranking coal. When the coal is called low ranked coal, when it is having high moisture level, high volatile matter. So this volatile matter can be organic matter and also inorganic, both organic and inorganic. And when it is called high coal, when it is high rank coal, when the carbon content is high. When the carbon content is becoming high, it becomes a high rank coal. So for any coal that is being mined, the total moisture that is present. So we have seen first is the moisture in the proximate analysis. First is the moisture. Second one is the volatile matter. So third one is the ash. Fourth one is the fixed carbon. So these are the 4 tests we do in the proximate analysis. So moisture is like 2 types. Surface moisture, surface, on the surface, the coal having the moisture on the surface, just on the surface, adherent is called as surface moisture, and inherent moisture within the coal inside, the complete matter having the moisture. So that is the surface moisture and the inherent moisture. So these are the moistures that are present in a coal. The mineral matter, it can be volatile mineral matter and ash that is present. So minerals what are present, elements or any others, will be present in the form of volatile mineral matter or in the form of ash. So organic matter in the form of organic volatile organic matter or fixed carbon. So this should be large. And also volatile matter comes in both the mineral matter and the organic matter. So whenever we have organic volatile organic matter and volatile fixed carbon, it is free of mineral matter. It is called free of mineral matter. So as received, this is the as received from the mining. So once we mine, after mining, we have all these in that particular coal. But once it is dried, once it is air dried, what happens? It will have only inherent moisture from this level to this level. Only these are present, because once it is dried, the surface moisture will be removed. So after drying, after chemically drying it, then with the apparatus, what happens? The complete moisture will be removed. Only mineral matter and organic matter will be present. So then what happens? Then after ashing, it will be ash free. So after ashing, at this stage, it will be ash free. Then after that, if we remove the volatile matter, it will have only fixed carbon and organic matter. So that is how the step-by-step analysis is done, so that it will have fixed high content of fixed carbon. So these are the additional characteristics of coal. Sulfur content. So coal with sulfur greater than 5% is not recommended for combustion. Why? Because sulfur is hazardous. So if there is a coal with high sulfur, that will emit harmful gases into the atmosphere and also harmful to the humans. Then weatherability. It is weathering or slaking index is nothing but reducing degradation, disintegration. So these are the different types where coal gets disintegrated. So this is indicated with weathering or slacking index. So an indication of size stability. It denotes the tendency to break on exposure to alternate wet or dry periods. So it should also have a moderate weatherability, so that it is helpful for any applications. Then grindability index. So this is a measure of relative ease of grinding coals or the power required for the grinding coals in a pulverizer. So this also makes an important characteristics other than the chemical analysis. Then burning characteristics of a coal: free burning coals and caking coals. Caking index: pulverulent, sintered, weak caked, caked and strongly caked. So what is caking? It is the ability to form mass or some masses. It's okay, like its ability to form some masses when it is coming together. So it should have free burning coal. The coal should be burning very freely. So the caking of that particular coals is also considered before it is applied in any applications. Then as fusion temperature, the temperature where the ash becomes very plastic, or like fusion temperature, like it becoming tars, in that case, fusion temperature plays an important role. Design of ash handling system: stoker furnace cannot use low ash fusion temperature coals. So these are the different characteristics that are again considered other than Proximate analysis. These are the additional characters to be considered before we go for any applications. So coming to the main important proximate analysis. In order to assess, there are two types like proximate and ultimate. So this determines the moisture, volatile matter, ash and fixed carbon. So this is very important in giving the information for any classification and suitability. So this will give an information for classification and suitability for any application. So the first one is the moisture. So how do we test for the moisture, examine the moisture content in the coal? We take 1 gram of coal sample. So generally a coal sample is taken, heated around 100 degrees centigrade. Why? Because the water temperature is 100. So it will be whatever the water that is present in the form of moisture will be removed at this temperature. So it is heated at 100 degrees centigrade for approximately 1 hour and the sample is weighed. So we will see in detail about 1 gram of finely powdered air-dried coal sample is weighed in a crucible. So this crucible is kept inside the hot air oven, electrical hot air oven, maintained at 105 to 110 degrees centigrade. So we maintain the temperature from 105 to 110 degrees centigrade for 1 hour. So 1 hour. So the crucible is allowed to remain in the oven for 1 hour and then taken out, cool in a desiccator and weighed. So after cooling, cool to room temperature and then weighed again. So loss in weight is reported as moisture. So simple technique we are using. So the percentage of moisture is loss of weight. So how do we do the loss of weight? Wherein this is the weight of the sample we take and this is the weight of the sample after the heating process. So divided by subtracting these two and divided by the weight of the sample into 100 gives our percentage of moisture. So this is W is the weight of the sample that we take and X is the weight of the sample after drying, after heating. So difference of these two will give the actual weight. So the difference of these two gives the weight that is lost. So divided by sample weight into 100 gives the percentage of moisture in that particular coal. So this is the crucible. Once we take the sample, this is the crucible. We take sample in the crucible. Then weigh 1 gram of sample in the crucible. And then hot air oven, keep it in the hot air oven at 105 to 110 degrees centigrade, hot air oven. So we while weighing we have to take precautions in not to spill the sample onto the weighing balance, and also with the lid and the crucible should be kept in the oven. Then after that, this is a desiccator we use. So this is how it looks, the desiccator, after we transfer the crucibles into the desiccator. So this desiccator is used for cooling to room temperature. So it has the crucibles. So this after cooling to room temperature, we transfer to the weighing balance again and we take the weights. So this is the next weight that we are taking. This is the first weight that we are taking, percentage of moisture. So what we are doing, first weight, weight of the sample minus weight after heating into weight of the sample into 100 divided by weight of the sample into 100. This gives the percentage of moisture present in coal. Next is the volatile matter. So the dried sample of coal that is left in first step. What is the first step? This step is moisture step. So the sample that is dried in the moisture step is taken as such and is then covered with a lid. So this is again covered with a lid and placed in an electric furnace. So now we are using muffle furnace. In the moisture we only used oven because the temperature is low. Now the muffle furnace is used because we are heating the sample at 925 degrees centigrade, so that most of this volatile matter or the organic volatile matter will be removed at higher temperatures. So at this high temperature we keep for the 7 minutes of heating. So we keep for about 7 minutes. So then the crucible is cooled and then kept in the desiccator, and again weights are taken. So this loss of weight is reported as volatile matter on percentage basis. So percentage basis, percentage of volatile matter is equal to loss of weight due to removal of volatile matter divided by weight of coal sample taken into 100. So this gives the volatile matter that is present in the coal. So this volatile matter can be combustible gases like methane, hydrogen, carbon monoxide and other hydrocarbons, or non-combustible gases like carbon dioxide and nitrogen. So all these will be removed in the volatile matter. So here what we are doing exactly, we are taking X gram of sample. For example, in the moisture step, X gram of sample is remaining. So that X gram of sample is taken and heated at 950 degrees centigrade for 5 to 7 minutes, and the sample now is becoming Y grams. So Y grams now is becoming Y grams after heating. So this crucible with the lid is kept in the muffle furnace at 950 degrees centigrade for 7 minutes and then transferred to desiccator. And weights are taken. So this volatile matter will remove. It is done in the absence of air. So it is done in the absence of air so that it can remove most of the organic volatile matter at these high temperatures. Removal of organic volatile matter. So except what happens, except for moisture which is again removed, which is already removed in the moisture step, that is containing a mixture of short and long chain hydrocarbons, aromatic hydrocarbons and some sulfur. So measured practically by loss of weight. So all these are removed in the moisture step. So therefore, only organic and inorganic volatile matter is only removed in this volatile matter analysis. So then it consists of mixture of gases, low boiling point organic compounds that condense into oils upon cooling and tars. So what happens if we don't remove this volatile matter? Upon cooling, it becomes oil. So that is why we need to remove volatile matter before we do for any applications. This presence of volatile matter will decrease the rank. So therefore, the volatile matter must be decreased so that the rank of that particular coal will be increasing. And what is the significance? A high presence of volatile matter indicates a large portion of fuel is burnt as gas. So we have seen it contains hydrogen, nitrogen, carbon monoxide, so on. So it is really burnt as a gas and that doesn't give any energy for a purpose. So or may escape unburnt or can remain as such. So the high volatile matter content gives long flames, high smoke and low heating values. So it gives long flames. It means the flame will be very long. So as we see in the anthracite, it will be very short and blue flame. These long flames will be red colored and long flames which will have low energy. So it also gives high smoke because this red content will have mineral matter like sodium, calcium, magnesium ions are not removed, so that it will give smoke. So that is why it is very important for removal of both organic and inorganic volatile matter, so that organic and inorganic matter, so that it will not give smoke. Thus, the higher the volatile matter content, larger is the conversion space required. So, it requires a larger conversion time, so that the volatile matter is high, because whenever the volatile matter is high, it takes large time for the conversion process. It is of special significance in coal gas manufacture and in carbonization plants. So, removal of this volatile matter is important in the coal gas manufacture and carbonization plants. The high volatile coals do not cake well. Around 25 to 30% of volatile matter containing coal yield hard and strong coke on carbonization. So, this whatever the volatile matter is present, if it is 25 to 30%, that will yield hard and strong cokes on carbonization. So then is the ash content. Next comes the ash content. Coal contains inorganic mineral substances which are converted into ash by chemical reaction during the conversion of coal. So it has mineral substances, mineral matter that is converted into ash by chemical reaction during the conversion of this coal. So ash contains silica, alumina, iron oxides and some small quantities of lime and magnesia. So these are the inorganic mineral substances that are present in a coal that is converting into ash. So what happens? We are taking a coal sample and heating it 500 to 700 degrees centigrade, whereas there it is forming ash. So the residual coal in the crucible 2. What is 2? Second step, volatile matter. Volatile matter that is left over, that is Y grams. That is left over is then heated without lid. So in the presence of air in a muffled furnace at 700 degrees centigrade for 1 hour. So the crucible is then taken out, cooled first in air, then transferred to desiccator and weighed. So in this also we are, after removing the volatile matter, the same sample is again transferred to muffled furnace and here treated at 700 degrees centigrade for 1 hour. So upon heating at 700 degrees centigrade, any inorganic or mineral matter will be becoming ash. So this ash is weighed after cooling in the desiccator. Heating, cooling and weighing is repeated until we get a constant weight. Why we need to get a constant weight? Because even if there is presence of any volatile matter present or moisture present, it will be removed. The constant weight has to be reached so that it has no other contents other than the ash whatever are present. So that is why we require to take constant weight until we need to take weights until we get constant weight. For example, if we got Z grams, so it should be Z grams again for next, or 1 gram, it should be again 1 gram. Even if it is 1 gram and if it is 1.2, or if it is varying, or 1.2 and it is 1.1, then we have to take a weight again, it should be 1.1 again, then we can stop. This we can stop. Otherwise, if the sample is going to be 1, we have to repeat it until we get 1. So that is how we take weights until we get constant weight. The residue is reported as finally as ash percentage. So the weight of ash left over divided by weight of the coal taken initially. Which weight we are taking? Initial coal weight into 100. So that will give rise to ash content. So this is the sample why we are taking from volatile matter sample. is continued to heating at 750 degrees centigrade in the muffle furnace, 750 degrees centigrade. This is the crucible that is used. So we are transferring, the same crucible can be used. So we are transferring to muffle furnace, and then after 1 hour we are weighing it sample after we are cooling in the desiccator. So this is the formula we use for ash content. So the sample from the moisture, only the initial weight we are taking in the moisture, but the same sample is continued for these different steps of analysis. Next is the fixed carbon. So this it is determined by subtracting the sum of total moisture, volatile matter and ash contains from 100. If it is 100%, from 100%, whatever we remove all these from the 100%, so that we get whatever the carbon is present in that particular coal. So moisture, volatile matter and ash, all these three will be removed from 100%, so that we get actual fixed carbon. So percentage of fixed carbon is equal to 100 minus percentage of moisture, volatile matter and ash. So this gives the fixed carbon percentage. So high percentage is desirable, that gives high energy and is very useful for any practical applications. So in summary, if we see, this is the first percentage of moisture, loss of weight by coal, weight of the coal taken into 100 gives the percentage of moisture, percentage of volatile matter, weight of loss of weight due to removal of volatile matter by weight of the coal sample taken into 100. Then third one is the ash, weight of the ash left by weight of the coal initially taken into 100 gives the percentage of ash. Then fourth one is the percentage of fixed carbon. So 100 minus all these remaining three will give the carbon percentage present in that particular coal. Then if you see the significance or importance of this particular analysis, proximate analysis, in the moisture what happens? High moisture content in the coal is undesirable. We really doesn't require this moisture in the coal. So that will increase the heating time because it reduces the calorific value, increases the consumption of coal for heating purposes. It also increases the consumption of coal. More coal is required to get some energy. So it also lengthens the time of heating. And hence less moisture content will be like better in the quality for the coal. Less the moisture, the better the quality will be the coal. So however, presence of moisture up to 10% produces a uniform fuel bed and less of fly ash. So moisture content is very dangerous, like it will increase the consumption of coal in producing energy, so it will also increase the heating time. So it is always better to reduce the moisture content. Obviously it will then increase the calorific value. Volatile matter, during burning of coal, certain gases like carbon monoxide, carbon dioxide, methane, hydrogen, nitrogen, oxygen and hydrocarbons that come out are called volatile matter. So all these are the volatile matter that are present in a coal. So coal with high volatile content ignites easily, it lowers ignition temperature, burns with a long yellow smoky flame. So we don't really require this smoky flame, and that will have low calorific value. The calorific value goes down. Will give more quantity of coal gas when it is heated in the absence of air. But even if there is volatile matter present, that will reduce the ignition, the calorific value for that particular coal. So it is always important to reduce the volatile matter present. Then the ash content. Ash is a combustion product of the mineral matter present in the coal. So it consists of silicon oxide or silica, alumina and iron oxide with varying amounts of other oxides such as sodium oxide, calcium oxide or magnesium oxides. All these comes under mineral matter. So this mineral matter also is very important to remove because that also will give yellow smokes. So ash containing oxides of sodium, calcium, magnesium melt early. So low melting ash will be forming. So during coke manufacturing, the low melting ash forms a fused lummy expanded mass which blocks the interfaces of the grate. So what happens when we are manufacturing coke from the coal? What happens? This presence of these oxides will make its lummy. It becomes a mass-like structure, so that it will block the spaces that are present. So they will be obstructing the supply of air, leading to irregular burning of coal. So that is also a loss of fuel. So high ash content increases transportation, handling, then storage costs, and also it is harder and stronger. So when we have high ash content, all these problems arise like transportation, handling, and storage costs, because it becomes harder and stronger. So it also has a low calorific value, therefore it is very less for the usage. The fixed carbon is the pure carbon present in the coal. The higher the fixed carbon content of the coal, higher will be its calorific value. So carbon should be higher in content. Greater the percentage of fixed carbon, smaller will be the percent of volatile matter. So therefore the calorific value will increase. This also represents the quantity of carbon that can be burnt by primary current of air drawn through the hotbed of fuel. So higher the carbon, the quality will be better, high the calorific value. Hence, high percentage of fixed carbon is desirable. The percentage of fixed carbon helps in designing furnace and shape of the firebox, because it is the fixed carbon that burns in the solid state. Whatever is there, it is the fixed carbon that is burning in the solid state. So the coal, whatever is there, should be of carbon highest percentage, so that it gives more energy. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.